Hi, my scientists. How are you doing? Miss Ricketts here. And we're going to do some science today. We're going to do a continuation about sinking and floating, what we did last week. Now, we're not poolside. We're not in the Bahamas. We're not in Jamaica. We're back in our science lab getting ready for school to start. Now, last week, we talked about objects that floated on top of the water and objects that sank to the bottom of the water. Floated on top, remember our movements? Sank to the bottom. And we kind of looked and made a T-chart and made some observations, and let's go back and review. Here I have my concept wall, and I have a bottle, and the blue represents the water. And I have float on top and sink on the bottom. Float on top and sink on the bottom. Now let's see if we could take a closer look to see which objects floated. So here we are with a close-up shot of float, and of course I use the word less dense, and we're going to come back to this whole concept of density and sinking and floating in the water in just a minute. But let's go back to floating. We notice that the craft stick, the wooden bead, both things that are made of wood, floated. So I can make a prediction if I put a toothpick that's also made of wood, what it would do if I put it in water. And we notice the plastic and the foam sheet both floated in water. So we kind of can make a prediction if I have something that's plastic like the straw or foamy like the foam sheet, what it will do, probably float. Then I have the ping pong ball. It floats on top of the water. Interesting. Now let's take a look at some of the things that sank. Now we have a close-up view of the things that are sinking in water. I have the golf ball opposed to the ping pong ball. I have a rock, and I have these metal things. I have a metal bell and a metal ring. Both of these sank. So if I gave you another metal object, what do you think it's going to do? Sink or float? Probably sink because it might follow this trend or this pattern. So now that we see the objects that float on top of the water and sink on the bottom, and we notice that the ones that float, some of them are wood or plastic, some of them are bigger than the ones down here. Some of them that sank are smaller, so size doesn't have everything to do with it. These are metal. We talked about all these solids, but what about liquids? What can we do with liquids? Do liquids sink and float on water? But I want us to take a step further. We've been using the word sinking and floating for years. I want us to use the phrase density and relative density. Relative to what? To water. And the scientist, the very scientific form of float is called less dense, and the scientific form of sink is more dense. So let's take a look at our vocabulary words. Picture of vocabulary. Matter, anything that has mass and takes up space. Matter. Mass, the amount of matter in something measured in grams. Mass. Density, how much mass a substance has in a given space. Density. More dense, to drop below the surface level in a liquid. Sink. More mass per volume. More dense. Less dense, to stay on the surface of a liquid without expending energy. Float. Less mass per volume. Sink, to drop below the surface level in a liquid. Sink. Float, to stay on the surface of a liquid without expending energy. Float. Now let's take a look at this side. I have both the original words that we used in relationship to floating and sinking on the left-hand side, and our new vocabulary terms dealing with density on the right-hand side. So that you can see that when we say float, in our context, it means the same thing as less dense. When I say sink, it means the same thing as more dense. Float equals less dense, sink equals more dense. And we're back, and we're still in the lab. Now, we just got finished looking at solids and seeing which solids sank, hit the bottom, or floated, or on top of the water. Now, we're determined to use our new vocabulary, not just sink and float, but more dense and less dense. Let's do our hands. More dense, sink. Less dense, float. And you got to do the voice too. It doesn't work without the voice. More dense, sink. Less dense, float. That's right, I did that. And remember our example. There are more objects crammed into this same box. More objects, more dense compared to water, sink. There are less objects in the same container that takes up the same space, float. Float, less objects, less dense. Sink, more objects, more dense. And we did that with solids. Now, I've got some liquids, and I've got something fun to show you. Do liquids sink and float? Are there different densities according to liquids? Let's find out and create a density tower. So let me show you the materials I have. I have light corn syrup, some soap, some colored water, and some vegetable oil here. And let's have some fun. Now I'm going to start, because I know this, with the heaviest thing first. And here's my density tower. So let's go. I'm going to pour the corn syrup in. I might be able to pour this whole thing in. Look at it. It's not colored, but you can see it. Look at, oh, look at, glunk, 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 glunk. Oh, okay, maybe that's enough. Good. It's not flowing to the top. Corn syrup. And we're going to talk about these in terms of density. Now, isn't this a pretty color? I have some soap, some liquid dish washing detergent, and I'm going to slowly pour it in. See what happens. It goes down, but it goes back up. Down, look, down, but it comes up. I'm not telling it to come up, it's just coming up. Going, 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 going. Wow, isn't that beautiful? That is gorgeous. Let me leave some room for the other things. Now let's stop right here. Do you see that the soap is on top and the corn syrup is on bottom? The soap floats on top of the corn syrup. But let's use our words. The soap has less density compared to the corn syrup. The corn syrup has more density or a greater density compared to the soap. Why? Because it's on the bottom and this is floating on the top. Just that simple. Floating, sinking. But let's add some more. Let's have some more fun. You want to? Okay. Water next? You want water? Okay. I have some water here. Now we got to slowly pour it in. And I want you to see it kind of goes down, but it comes back up. It goes down, but it won't reach all the way to the bottom of the soap. And I'm slowly pouring it in, slowly pouring it in. You can see the difference. It's not really mixing. There's a line that it's really not crossing in the end. Look, look, see? It went down, but it came back up. Wow, that's beautiful. That's water. The water is on top of the soap. Let's bring our model. Less balls, less dense, float. More balls, more dense, sinks. So we would say like this. The water is less dense compared to the soap. The soap is more dense compared to the water. It has a greater density, more density compared to the water. You ready for some more? Let's do one more. This is cool, isn't it? And you have these household products at home. Vegetable oil. What do you think is going to happen when I pour this vegetable oil in? What do you think? Make a prediction. I see you out. Yeah, I see you. Kenya, Aaron, Jose, Maria, I see you. What do you think is going to happen when I pour the oil in our container? Let me give you some think time. Is it going to mess the whole thing up? Is the oil, because it's thicker, going to go to the bottom? This is thick. The corn syrup is thick. It went to the bottom. Do you think that same thing happened to the oil? Because, you know, the water is a lot thinner than the oil. But let's find out. Here we go. Here we go. Here we go. I'm going slow. I'm going slow. I'm going slow. I'm going slow. Now you're starting to see the difference. Can you see that the oil is up here and it's a little bit lighter? Here's the water down here and it's dark. Here's the oil and it's lighter. And if we don't move it, you're going to see that it's going to separate some more. Oil, water, soap, corn syrup. Okay, now it's time for our 2D Think Aloud relative density addition. And let's take a look at this. Our first speaker, we have water and oil, with water on the bottom and oil on the top, which means that oil is floating on the water. But let's use our density phrases, our density vocabulary. That means that water has a greater density than oil. Oil has less density than water. In our second beaker, we have oil and a cork. Look what's floating. The cork is floating on top of the oil. So let's use our density vocabulary. Oil has a greater density than the cork because it's on the bottom, it's sank to the bottom. Now that we described our pictures and we have our visual literacy going, what if I had a third container where that question mark is? And I added container 1 plus container 2, what would that third container look like? What would it look like? So let's do a think aloud so I can model my thinking to show you how I would answer this question. One thing that I do to help me answer questions like this is that I color code. So for the water, I would come over here, put my little water here and my oil here, plus my oil over here and my cork here. You with me so far? Everyone say color coding. Thank you, my students. Let's go to the next slide. Now that I've color coded everything, I've added another beaker, my third beaker to this. So let's see what we're gonna do. Now that I have this set up, I'm gonna start matching. What do you mean matching? I wanna match my colors together. Here's my second beaker. Am I gonna put the yellow and blue here? No, I'm gonna put my yellow and yellow together so that my oil will look like this. and the cork like this. So I know when I make this next third beaker, I'm going to start with water, then oil, then a what? A cork. So let's go ahead right now and insert some shapes. And I'm going to get this water, insert it, pretend it fits. And I'm going to get these two oils, the yellows, because that's next in my picture when I match the colors up, and insert it. I'm going to have more oil. Now it's yellow, it's blue here, so I'm going to change that color to yellow. Uh-oh, wrong one. Undo. Here we go. Click on it. Now change it to yellow. There we go. And then, of course, I need my red cork. So let's get to a shape. Do my little circle and fill the shape in with red. Do you see what I did? The secret is I matched the yellow. That's how I thought about it initially. But let's go ahead and use our vocabulary terms. Here we know that water has a greater density than oil. Oil has a greater density than the cork. I put it together so that oil will be with oil when I pour them together. The oil will go together with the oil. The water will still have the greatest density, and the cork will still have the least density when we put it all together. We did it 2D, paper and pencil or computer. Let's take the time to do a 3D and actually use oil, water, and a cork. Now we just made a density column, and we saw that even liquids have density, that some things sink, go to the bottom, have more density compared to water, and some things float above or on top of the water. So let's do a little relative density math. Here we go. I have some water. And it's kind of dark. Let me lighten it up. I have some water here. And I'm going to pour some oil in this container of water. Now, what do you think the oil is going to do? Let's make a prediction. How many of you think the oil is going to float on top of the water? How many of you think they're going to change places and the oil is going to go to the bottom and the water to the top? Let's find out. Take my oil, slowly pour it, slowly pour it, slowly pour it. What happens? The oil rises to the top. It floats on top of the water. Now let's use our density words. You know Ms. Ricketts likes to use our new vocabulary. Which box would represent the oil? This box, number 1, or this box, number 2? I'll give you some think time. This box, number 1, represents the oil because it's floating on top of the water. We think in our mind that because oil is thicker than water, it's heavier, but for its size, it's not. It's floating on top of the water. Box B or 2 would be the water. This will be the oil and water. So here's my first container. The oil is less dense compared to the water. The water is more dense compared to the oil. So let's do something else. I have my oil. I'll pour it in. will put a ping pong ball in here. What do you think is going to happen once I pour the ping pong ball in the oil? Now I have a solid and a liquid, and I'm comparing the densities of the two. Relative density, comparing the two. I'll give you some think time so you could think of what's going to happen once I put the ping pong ball in the oil. You have a prediction? Ready? Drum roll, please. It floats. The ping pong ball floats on top of the oil. Now let's use our density. The ping pong ball would be the top one. Oil will be the bottom one in this instance. Let me move this out the way. Less dense, more dense. So the ping pong ball has less density compared to the oil. The oil has a greater density compared to the ping pong ball. But let's take it a step further, shall we? Container number 1 plus container number 2 will give us container number 3. What's going to happen when I pour these 2 containers into this container? Hopefully I don't overflow the oil. What do you think is going to happen? Are they all going to be mixed up? I don't think so, since they're not mixed up here. Which substance will be on the bottom? Which substance will be in the middle? And which substance will be on the top? I have 3 objects here: the water, the oil, and the ping pong ball. Make a prediction to think about what's going to be on the bottom and have the greatest density, what's going to be on the top and have the least density. Let's find out. Ready? I'm adding this one in here. No change. Now let's add this in here. What's happening? What do you see? I see water on the bottom. I see oil separating from water in the middle, and I see the ping pong ball at the top. Did you come up with that? Was your prediction right or wrong? Let's look at it. The ping pong ball was on top of the oil. It still is. The oil was on top of the water. It still is. So when we added these 2 cups together, we got this one. The ping pong ball has the least density, the water has the greatest density, and the oil has the middle density. Isn't that interesting? Relative density math. And now we're back. You've been waiting for. No lesson on density would be complete without, drum roll please, do-it-yourself lava lamps! Ah! So I brought my real lava lamps from home. Can you see them? This one is blue and this one is rainbow. And the whole concept of a lava lamp is based on relative density. And I'm going to show you what you need. You're going to need water, oil, and Alka-Seltzer tablets or some sort of fizzy tablets. Water, oil, tablets, and we're going to do some food coloring. Are you ready? Because I am. Are you ready? Because I am. Remember, this works because the water has a greater density than oil, but here is the added little secret. This supplies the gas, which when combined with water moves up because gas has the least amount of density of all three of them. That's why it circulates. Ooh, this is so much fun. This is so much fun. Here we go. Let's see if Miss Ricketts, some water. Right here. Move it over so you can see. Water here. Different amounts. Water here. Oh yeah. I like to mix it up. Let's get some more water. Water here. We already have water in this one. Some water in here. Let's put some water in this one. Oops. Some water in this one. Some water in this one. Very good. Here we go. Are you ready? Fantastic. Oh, we have more assistants coming in, my scientists, and they might help us out. Now we have all this water. Let's start to color it. Put some blue in here. I want purple. All the colors of the rainbow. Let's get some green in this one. And this one. What else do we have? Do we have red? We already have red. Let's get some dark green. Yes, I can't wait for you to see this. And do we have any more? Oh, we have one more. Okay, hold on. It's coming. It's coming. It's coming. Do I have a pink? I thought I had a pink. Let's try this color. This is kind of an aqua color. Oh, that's pretty. Now, what do we need next? We need some oil. So let's get some oil. Now, we're going to put more oil than water in each of these. Now, remember, even though it may seem like it's thicker, the oil has less density compared to the water. The water has greater density compared to the oil. Let's put some in here. That's a pretty color. Let's get some more oil. Oh, I'm getting excited. Are you getting excited? I'm getting excited. Let's put some in this one. Can you see them? Remember, you have to do more oil than water. Take your time. Oops, don't want to spill it. We move this to the side. The purple. That's a pretty purple, don't you think? I love it. And remember, the oil is on the top. Why? Less dense. Here we go. Oh, here's a pretty dark green. Going. Okay. Let's put some in this one. Put some in this one. Assistants, what do you think? Do I have enough oil? Are we excited? Woo, woo. I'm sweating. Okay, here we go. Here are my Alka-Seltzer tablets. Let's see what happens. Can we see? Oh, look at it. Our lava lamp. And it's happening because the Alka-Seltzer is producing a gas which has the least amount of density. Yay! Woo! 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 Here it is with the golf ball and the ping pong ball. Cool! Look at this one. My assistant, do you have your camera so we can get a close-up? Now, let's do the one with the tower so we can get a close-up shot. Let's see what happens when we put it all the way in this one. Oh my goodness, isn't this neat? Yay! The gas bubbles have the least amount of density, but when they pop, that water goes back down. Oh, look at that one. Yeah. Cool. I've got some glitter. Let's look at the glitter. I think the glitter is just going to float on the top unless it gets, oh, it's starting to sink. We'll put some Alka-Seltzer in there and see, oh, that went down. You got some close-up shots, my assistant? Huh? Okay, you can get closer. Oh, look how pretty. Look at, come over here and take a close-up of this one. This is cool. Again, the water has the greatest density. Oil has less density, but the bubbles has the least amount of density. They have the least amount. So I want you to be able to do this at home, have some fun, make your lava lamps, and remember, it's Miss Ricketts here, and the world's your laboratory.